There are two kinds of decimals, simple and complex. A simple decimal has only whole numbers to the right of the decimal point. For example, 32 10,000ths is a simple decimal. Another example of a simple decimal is 0.56. A complex decimal has both integers and a proper fraction written to the right of the decimal point. For example, 32 10,000ths and 1/4 is a complex decimal. Another complex decimal is 0.56 and 1/4. Often, it is necessary to compare decimals to determine which is larger. For example, two pieces are 0.5 and 0.2 inches respectively. Which is larger? First, change the decimals to fractions where the denominator of the first is equal to the denominator of the second. 0.5 becomes 5/10 and 0.2 becomes 2/10. Next, compare numerators. 5 is greater than 2, so 5/10 is larger than 2/10. To compare a piece of wire 0.09 millimeters to another piece 0.011 millimeters, convert the decimal fractions to common fractions. Since the denominators of 9/100ths and 11/1000ths are unequal, multiply the smaller fraction by 10. Remember to multiply both numerator and denominator. You get 90,000ths. Compare this fraction to 11,000ths, and the fraction 90,000ths is easily identified as the larger. Sometimes it is necessary to convert a decimal to a common fraction. To convert 0.5 to a common fraction, first remove the decimal point. This is step 1. For example, to remove the decimal point, multiply 0.5 by 10. You get the whole number 5. Next, write in the indicated denominator. This is step 2. Since we multiplied by 10 to remove the decimal point, 10 is the denominator. Write the common fraction. In this example, it is 5/10. For step 3, reduce the common fraction to lowest terms. In this example, 5/10 becomes 1/2. Convert 0.33 to a common fraction. First, remove the decimal point by multiplying by 100. Write the indicated denominator, 100. Construct the fraction as 33 over 100. Since 33/100ths cannot be reduced, stop here. The common fraction is 33/100ths. To change a proper fraction to a decimal, divide the numerator by the denominator. Then, write the quotient in decimal form. For example, to change 1/4 to a decimal, divide 4 into 1. The answer is 0.25. Change 1 over 125 to a decimal. First, divide 1 by 125. The decimal becomes 0.008 or 8/1000ths. All common fractions must be reduced to lowest terms. In a similar manner, it is necessary to remove zeros from a decimal if the zero falls to the right of the last digit of a decimal fraction. For example, in 50/100ths, or 0.50, the zero on the end is unnecessary. The decimal can be read as 50/100ths, but it is easier to understand if read as 5/10ths. Both decimals equal the same amount. For example, 300,000 millionths is a difficult decimal to comprehend. It is easier to read this decimal as 3/10. Adding zeros to the right of the last decimal digit equal to or greater than 1 is equivalent to complicating the understanding of that decimal. Caution: some zeros are necessary as placeholders and should not be removed. 0.05 is equivalent to 5/100ths. Removing this zero is incorrect and changes the value of the decimal to 5/10ths, a larger number. Do not remove the decimal if the value of the decimal is changed. To round a decimal, first determine the place value of the decimal that you want to end up with. You might want to round to the nearest tenth, hundredth, etc. Suppose you decide to round to the nearest tenth the decimal fraction 0.56173. Locate the place value to the right of the place value you have chosen. In this case, directly right of the tenths column. This is the hundredths column. Locate the digit in the hundredths column, a 6. Remember when rounding that all numbers equal to or greater than 5 are raised to the next highest number. We have a 6, which is greater than 5 in this example. Therefore, we raise the number in the tenths column from 5 to 6. The number 0.56173 becomes 0.6 rounded to the nearest tenth. Suppose we want to round the same number to the nearest hundredth. Locate the number in the thousandths column. It is a 1. Since 1 is less than 5, we do not raise the number in the hundredths column by 1. Our number becomes 0.56, rounded to the nearest hundredth. If the decimal point is moved one place to the left, the decimal is divided by 10. For example, if 3/10ths is divided by 10, it becomes 3/100ths. Shifting the decimal point to the left moves the 3 from the tenths column to the hundredths column, making the decimal smaller. If the decimal point is moved 2 places to the left, the decimal is divided by 100. For example, for 3/10ths, the decimal point is moved 2 places to the left and becomes 3/1000ths. Moving the decimal point 3 places to the left divides a decimal by 1,000. 4 places to the left divides it by 10,000, and so forth. For 3/10ths, moving the decimal 3 places to the left, the decimal becomes 3/10,000ths. Moving the decimal point to the right increases the size of the number. Moving 1 place to the right multiplies the number by 10. Moving the decimal point to the right 2 places increases the number by 100. Moving the decimal point 3 places to the right multiplies the number by 1,000. Moving additional places to the right increases the number accordingly. For example, for the decimal 0.789, moving the decimal 1 place to the right becomes 7.89. 2 places to the right creates the number 78.9, and 3 places the number 789. The monetary system of the United States is a decimal system which uses only 2 decimal places. The basic unit is the dollar. Dollars may be divided into tenths, hundredths, and thousandths. There are 10 dimes in a dollar. 1 dime equals 10 cents, or 1/10 of a dollar. Since there are 100 cents in each dollar, 1 cent equals 1/100th of a dollar. There are 10 mills in 1 cent. 1 mill equals 1/10 of a cent and 1/1000th of a dollar. Since we do not have change in the form of a mill equal to or greater than 5 results in raising the price paid for any item by 1 cent. You deal with decimals each time you spend money. Suppose a dozen eggs costs $1.05. You want to buy 1 egg but need to know what to pay. First, divide $1.05 by 12. The cost of 1 egg becomes 8 cents 8 1/3 mills. Since you add a cent if the mills are equal to or greater than 5, the price of 1 egg becomes 9 cents. You buy another grocery item which costs 37 cents 4 mills. Since the 4 mills is not equal to or greater than 5 mills, you pay only 37 cents. You buy one item for $5.50 and another for $2.30. Adding 5.50 and 2.30, you get $7.80.